The growing global conflict between the construction of large data centers by tech giants, Amazon, Microsoft, and Google, and the increasing scarcity of water, particularly in drought-stricken regions. Here are some key points. First, the problem. Data centers require massive amounts of water for cooling, often built in water-scarce regions like Chile, Uruguay, and the southern US. This consumption directly competes with local communities and agriculture for limited water supplies. Second, case studies, Uruguay. Google's project faced protests during a historic drought for its plan to use millions of liters of potable water daily. Critics cite a lack of public dialogue and transparency. Chile, Google's data center plans were partially blocked by a court due to environmental concerns, forcing a likely switch to air cooling. USA, Memphis, a rapid AI data center build, linked to Elon Musk, caused local fury over a lack of transparency, potential pollution, and the prioritization of industrial water use over residents' needs. Third, the cooling dilemma. While switching from water cooling to air cooling seems like a solution, it is less energy efficient. This often leads to a higher indirect water footprint at the power generation source, for example coal, gas plants, unless renewable energy is used. A sustainable example, Sweden. The data center in Falun, Sweden is presented as a better model. It uses abundant local water, reusing it where possible, runs on 100% renewable energy, and repurposes waste heat for a district heating system. It also emphasizes community dialogue and sustainable building materials. Fourth, lack of transparency. A major recurring issue is the tech giants' refusal to disclose key data on their water and electricity consumption, making independent assessment difficult for researchers and communities. Fifth, future projections. Demand for computing power is exploding. Water consumption by data centers is expected to more than double by 2030, while electricity consumption is predicted to increase by 128%. Sixth, proposed solutions and goals. Tech companies aim to be water positive by 2030, though the specifics are unclear. The article suggests that building in water-rich, cooler climates and using renewable energy is more sustainable. It also concludes that individual choices, for example using a calculator instead of AI for simple tasks, can reduce the computing load. Core conflict. The central question is whether unlimited technological progress and the sustainable use of resources can coexist, or if society must choose between them.